So you have an integral, and inside the integral, you'll have a function, the derivatives of the function, these pick up in the same file. Okay? And it's the chain rule created the function in now rest. Yeah, this is throwing me off. The chain rule created the function in each side of it. Remember, for example, I had something like sine s cubed. You use the derivative of that. You got cosine of x cubed times 3x squared, right? So if you had an integral of 3x squared cosine x cubed dx, it's not obvious when you look at that this is going to turn into sine of x cubed. I mean, you guys certainly aren't at that level of sophistication where you just sort of look and go, oh, sure, that's sine of x cubed plus 6, right? What you want to do is you want to be able to look at some integral and figure out what the original function was, because the integral contains both the function and the derivative. And we do that through substitution. That helps us simplify the integral. So if, for example, I have the integral of okay, that's going to be one of these types of functions. It's going to be a function and its derivative. It's not exactly obvious what the original function is. You can probably play around and get there. But in the beginning, it might be a little tricky. So if we say, well, do I see a simplified function in there and its derivative? Well, the derivative of x squared is 2x. I got x, so that's pretty close. So if I let the letter u stand for 5 plus x squared, can you hear me back there?
Yeah.
Hey? Can you hear me? How about now? Alright. So if we let u equal 5 plus x squared, then du would be, well, du dx would be 2x. Okay? So if I cross multiply, I can du is 2x dx. So I look inside the integral and I say, well, I almost have 2x dx. I have x dx, right? I have x dx. So if I multiply by half, also divided by 2, I get a half of du equals x dx. So now I can go over to the integral, and I can substitute. So instead of being an integral in terms of x, it's going to be an integral in terms of u. But I can't have any x's left. It has to all be in terms of u. So I say, well, this is now the square root of u. That's easy to do. Easy integral. And x dx is 1/2 du. I put the half on the outside. When you're integrating, it's just like differentiating. Multiply by a constant. The constant just stays there. So you pull it out of the integral to make it easier to integrate. Right, this is the same thing as saying a half u to 1/2, right? So now we integrate that. The integral is 1/2 u to the 3/2 over 3/2 plus c, which with a little algebra is the same as 1/3 u to the 3/2 plus c. And now I just substitute back to u. The handwriting gets harder as I move down the board. So that's 1/3 of 5 plus x squared 3/2 plus 6. Okay? Alright. Let's do another one. Then you guys get to do a couple. cosine x plus 3, expand it out to the 10th, so it makes a little work. I can distribute cosine and probably get a whole bunch of messy integrals, but why would I do that? I look and I say, the derivative of cosine is minus sine, but that wouldn't be very useful, because then I'd have this would be u, and this would be du to the 10th, which is not helpful. But if I let u be sine x plus 3, the derivative of sine x plus 3 is cosine x, and this would now become u to the 10th, which is easy, and this would become du. So let's do the substitution. If I let u equal sine x plus 3, du is just cosine x dx. Okay? So if du is cosine x dx, and u is sine x plus 3. Now I substitute. This becomes u to the 10. This du. So usually when you do the substitution of these problems, you'll end up with a power rule or something simple like a sine or a cosine. Okay? Pretty much all we can give you right now. Maybe a log. We can end up with a log, which is sort of power rule. Okay, so this is u to the 11th over 11 plus c. And now you subtract, you substitute back. So you get sine x plus 3 to the 11th over 11 plus c. How are we doing so far? Questions? No? I don't know what you're doing, questions? I'm totally confused. I got it totally. I really understand. I want to leave. I'll just sit here and do Instagram. Yes? Alright, so first is you have to figure out what's going to be u and what's going to be du. So you can sort of do trial and error. But the idea is you want to find one function and its derivative. So I look here and I say, if I let u be cosine, the derivative of cosine is minus sine, it's kind of sine. But this would then be u, and this would be du to the 10th, which is weird. So I say, well, let's try the other way around. What if I let u be sine x? We're going to get u at plus 3, which isn't very useful. But if I let u equal sine x plus 3, du is just cosine x dx. And this becomes u to the 10th, and the remainder is just du. Okay? So I've substituted for all the parts. Sine x plus 3 to the 10th becomes u to the 10th, and the cosine x dx becomes du. Notice, I don't let u equal sine x plus 3 to the 10th. Okay? That's not helpful, because the derivative of something to the 10th would be 10 times the thing to the 9th. I just let it be what's inside the function. See, because having something to the 10th is the problem for integrating. Right? You just make it to the 11th divided by 11. What's inside that is this. So then I substitute, and now I just get u to the 11th over 11. And then I substitute back. Okay? Let's have you guys try a couple. There you go. There's 3 to start off. So you look at the first one, and you say to yourself, what do I do with that 7? Because that's annoying. You got the 7 there. Just take the 7 out. Oh, I heard that. Alright. Remember, you move constants in and out of the integrator as long as they're multiplied. Okay? So let u equal x squared plus 8. du is 2x dx. Now I look and I say, alright, this is u, and I have x dx, so I just have to play with the u for a second. Make that 1/2 of the u is x dx. So far so good? So now I substitute, and I have 7 times 1/2 times u to the 5th. U. That's 7/2. Or 3.5 if you're feeling desperate. Okay? So that becomes 7/2 times u to the 6 over 6 plus a constant. And then substitute that. So you would get 7 12 x squared plus 8 to the 6 plus c. To anticipate your question, no, you don't have to turn this into 7 12. You could leave it as 7 times a half, cut the thing over 6. That's fine. Okay? Simplifying is not important in a question like this. Demonstrate that you know what you're doing is important. Everything I own is covered in progress. This is cashmere. You know, you really shouldn't treat it this way. Alright, how about this one? Well, the 5, again, you can just take the 5 out. Now you could think of that if you wanted. Okay? Because log of x over x is the same as the log of x times 1 over x. You don't have to do this. But if it makes it easier for you, then u would be log of x, du would be 1 over x dx. If you ever become teachers, when you write on the board, step to the side, so the class can see what you're doing, rather than doing this. Students find very annoying. Just thought I'd share that teachable moment with you, in case some of you, out of desperation, rather than going to med school, end up in something terrible like this. I'm not dreaming. I'm actually living this television business, right? So u equal log x, and du is 1 over x dx. So now this is just the integral of u. Corey, you got a question?
No.
You sure? Okay. So, u is natural log of x, du is 1 over x dx. So this is u, and the integral of u is u squared over 2. And now you can just substitute back. So that would be 5 halves log of x squared plus a constant, which you could write in more than one way, okay? So far, so good? Alright. What about tan to the 6x secant squared x dx? Well, if I let u equal tan x, secant squared x dx. So now this is just u to the 6 du, which is u to the 7th over 7, plus a constant, so that's 10 to the 7th x over 7, plus a constant. Suppose I had something like that. That's annoying. Because what am I going to do u substitution on? Any ideas? I'm going to do u substitution. First, what's 1 minus cosine squared the same as? Really? You guys know that? That's amazing. So that would just be the integral of sine x. Don't forget your trig substitutions. Okay? Because we can make things trickier by first making you do a trig plane. So remember how we did the integral of tangent. Okay? You rewrite that first as sine over cosine, and it's a much easier integral. This is just minus cosine. Now I could do these as definite integrals. Let's do one of those. I like that one.
I used to do this.
By the way, when in doubt, just write pi. Hope it works. Pi, 0, 1, 100, what the heck? Maybe one of those will turn out to be the right answer. Pi is not going to be the right answer. Alright, that's probably long enough. So let's let u equal 2 minus e to the x. Negative e to the x. Yes. And that's almost what I have, except for the negative thing. The negative du e to the x dx. So leaving out the limits, this would now be negative integral of du over u. These are called the limits of integration. Now you could change the limits, okay, which we're not going to do today. You could change the limits and then do the whole integral in terms of u, and then you still have to change the facts. Okay? One step at a time. Let's learn how to do this first. So this is negative ln of u, which is negative ln of 2 minus e dx. Now, we're going to do that from 0 to ln of 4. Okay, what is e to the log 4? 4. Okay, make sure you know that. E to the log of x is x. So this becomes negative ln of 2 minus 4 plus log of 2 minus 1. Okay, notice how I have plus, minus minus. So far, so good? Okay, what's log 1? Log of 1 is 0. And the log of negative 2, but it's absolute value, so it's log of 2. This is negative log 2. Okay, that's why you have the absolute values. Sure. So I look at this and I say, I need to integrate. I need to do a substitution. I look at the denominator and the numerator, and I have to make u what's in the denominator. So then u equals 2 minus e to the x. The derivative of that is negative e to the x. The derivative of 2 is 0. And then, so minus sign here, so I can say negative du is e to the x. So I go over here, and now I say, okay, this becomes u. This becomes negative du. So the integral of du over u is the log of u, not log of the absolute value of u. So then I substitute back and get the negative log of absolute value of 2 minus e to the x. Now, I just have to evaluate that from 0 to log 4. So I plug in log 4, and e to the log of 4 is 4. And I plug in 0, and e to the 0 is 1. So this becomes log 1, and log 1 is 0. That's why I take that number. And this becomes the log of 2. That's it. My answer is negative log 2. You really want to show off log of a half. Okay? Yes? when I'm here. What's the root of the log u? Right? 1 over u. So the integral of du over u is log u. You should remember some of these integrals. It's like that. There's a time to do a little reviewing. Right? So you should know a power. You know the integral of e to the x. You should know the integral of dx over x is the log of half the side of x. I will make a handy review sheet of this for you guys tomorrow, and I'll post it somewhere in Blackboard. Okay? See, tomorrow I take a 2-hour train trip into the city, and about an hour and a half trip home from the city. So I could sit for the entire 3.5 hours and look at my phone and check out my Tumblr, but I have life. So instead, I'm going to write calculus stuff. Wait, that's not a life. So because I don't have a life, I will write you guys a review sheet tomorrow and some practice problems. We don't have a practice exam yet, so that's part of tomorrow. I'll put up the practice exam probably Friday morning. I will not put up the answers Friday morning because I will be tired and irritable. Because I won't be Thursday night, ladies' night at bench. No. I will be doing calculus. How do I know about that? Alright, so again, just to go up over the weekend. I don't know if any of you used to go to Jake Star across the train station. It just closed. Really sad. It's going to be a new Italian restaurant. So we have a nice big place across the train station.
I like the signature.
And it's a new Chinese restaurant.
That's the signature of boss.
So you got the Sweet Frog yogurt place.
I know, it was so really funny.
So it's
What's talking about today? Maybe it wasn't kind of their time.
That's what I was told. We'll see if it turns out to be true. Am I forgetting any? Oh, sure. This is the secant x. We got a minus on. That's minus. You can't tell if it went from handwriting. I'll erase that and replace it. Okay? So far, so good? Alright. Let's do some other stuff. The function f of x equals 3x squared plus x. Hey! Find the area of the rectangle. Find the area of the curve from x equals 1 to x equals 9 using 4 rectangles. Right-hand rectangle. B. Write a Riemann sum for the area using n rectangles. C. Evaluate the Riemann sum. We want to find the area under f of x equals 3x squared plus x equals 1 to x equals 9 using 4 right-hand rectangles. So, our curve is doing something like that. It's not a good way to draw it. We're going to find this area. We're going to make 4 rectangles. So we do right-hand rectangle. So you take it, 1, 3, 3, 5, 5, 7, 7, 9. Go to the right.
It's hard.
Find the height of the rectangle. We're overestimate. And L is big a number. Okay, the width of each of these rectangles is 2.
Did the fight for a while.
So the height of the first one, F evaluated at 3, then F of 5, then F of 7, and F of 9. Okay? You take 3 and you put it in. So 3 times 3 squared is 27. Plus 3, this is 30. 3 times 5 squared is 75, plus 5 is 80. 3 times 7 squared is 147, plus 7 is 154. 3 times 9 squared is 253, plus 9 is 102. So that's 1,032. Did I get that right? Okay. I was a little slow on that one, sorry. Okay. How was that? That was right? Okay. Few wrong. Alright. Now, let's write a Riemann sum. For Riemann sum, you have to just sort of think about what's going on, but you want to do it in terms of I. And you want to think about how wide each rectangle is. So each rectangle is all over 2 wide. Each rectangle is now, well, I don't know. You take 9 minus 1, divided by n, and you get 8 over n. So that's how wide each rectangle is going to be. Do it up here. Okay? And the first one is it going to be an f of 3? Well, no. It's going to be an f of 1 plus 8 over n. The next one is going to be an f of 1 plus 2 8 over n. And 1 f of 1 plus 3 8 over n, etc. Okay? And the last one will be f of 1 plus n 8 over n. Well, n over n, that gives you 1 plus 8 is 9. That's what you want. So again, how do we come up with this? We say, well, I start at the left end point, and how the width of each interval is 8 over n. Why is it 8 over n? Well, because this is 8 wide, and I'm dividing it into n rectangles. So I'm going to take the first point, 1, and I'm going to move 8 over n to the right. And that's the right endpoint of the first interval. Then from there, I move another 8 over n to the right. So that's why it's 2 8 over n's. And then I move another 8 over n to the right. That's 3. And I keep doing this n times. And the last one, you should check your arithmetic should come out the right-hand number. It should come out 9. Okay? So, erase that. I'll rewrite it. So what I'm writing here is identical to what's over there. 8 over n, f of 1 plus 8 over n, plus f of 1 plus 2 8 over n, plus f of 1 plus 3 8 over n, dot, 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 f of 1 plus n 8 over n. Okay? So that's my Riemann sum. Now, you just sort of put it in sigma notation. This is the fun part. Okay, well that's 8 over n. So you're always going to have the same thing in your sigma notation. This will be the width. So that will be b minus a over n. This will always be I equals 1 to n. But inside, you're just going to have f at the left end point plus the width times I. Okay? That's what your Riemann sum looks like. Then you just have to take f and replace it with 3x squared plus x. and I have f, and I'm going to start at 1, and I'm going to keep adding 8 over n. So I'm going to have 8 over n, that's the width each time, times I. Okay? Yes?
Why is it 1 plus?
We're doing right-hand rectangles, okay? So I'm going to take the leftmost endpoint, which was 1, but then each interval, remember, use the right-hand side of it. So each rectangle is 8 over n wide. So I have to start at 1, I have to move 8 over n to the right, and then another 8 over n to the right. Okay? So we're doing left endpoint rectangles. This would be 0, and that would be n minus 1. But all our formulas work better from 1 to n than from 0 to n minus 1. Okay? Now the last step to get it exactly right is instead of f, so I recommend if you do this on the exam, if you have a question like this, write out all these steps, get all your partial credit. So f is 3x squared plus x, so it's going to be 3. X is this, 1 plus 8i over n squared plus x, which is another 1 plus 8i over n. That's a pretty handwriting. Like wedding invitation. So far, so good? Alright. Now for the really fun part, evaluating this. I know you want to do this. I don't know if we're going to have this on the exam. I know if we have put it up to a vote, I know what the answer would be. If we do have it in the exam, I suggest you do the problem last. Okay? Because it's time consuming. Work on other stuff first. Do the stuff that you're comfortable with. Okay? These are annoying. I have trouble with them. Okay? They're very tedious. It's easy to make mistakes. But we know what the answer has to now, right? This has to be the integral from 1 to 9, 3x squared plus x. Is x cubed plus x squared over 2 from 1 to 9. Okay? So you have to get that number. So when you do it this way, you get the same answer as where you get there. Okay? It's not a fun number. I think it's 688, but I think we know that. It's hard to do in my head. Alright. So now how do we evaluate this? Well, we got 8 over n, sigma, 3, times, multiply that out. That's 1 plus 16i over n, plus 64i squared over n squared, plus 1 plus 8i over n. All I did was FOIL out this. Where's the 64 coming from? 1 squared, 2 times 1 times 8 over n, which is 16i over n, plus 8i over n squared, which is 64i squared over n squared. Okay? Let's do some simplifying. I'm not going to write I equals 1 over n. My hand gets tired of that. So this 3 times 1 is 3, plus 1 is 4. 3 times 16 is 48, plus 8 is 56. 3 times 54 is 192. I squared over n squared. Starting to get easier. Okay. Okay. 3 times 1 is 3, plus 1 is 4. 3 times 16 is 48, plus 8 is 56. 3 times 64 is 192, plus nothing. Still 192. Okay? Skip 2 steps. I don't recommend you skip any steps. Okay? I pity the TAs who have to grade questions like this. No way. sum I equals 1 to n of 4 plus 8 over n times the sum I equals 1 to n of 56 over n plus 8 over n, the sum from I equals 1 to n, 192 I squared over n squared. You think this is annoying? Try writing it in chalk while you're shouting at the same time. Okay. So, 8 over n, sum I equals 1 to n of 4 is just, you take the 4 and you multiply it by the n. So that's just 8 over n or n, because that's this formula. Okay? I equals 1 to n is a constant. Just a constant times n. The n's cancel. This comes out to 32. We haven't even done the limit yet. Oh, yeah, when you write the Riemann sum, you have to write the limit as n goes to infinity. Kind of forgot to put that in there. When we're all done, we'll take the limit. Okay. The middle term, we have 8 over n. Sigma I equals 1 to n. 56 I over n. So 8 times 56 is 448 over n squared. So I can take 8 times 56 and n times n, pull it out, times the sum I equals 1 to n of I, which is 448 over n squared times. So this one is n times n plus 1 over 2. That simplifies to 224 times n plus 1 over n. Okay? 448 over 2, 224. One of the n's cancels, and the left is n plus 1 over n. We're not done. Then I've got 8 over n times the sum I equals 1 to n of 192 I squared over n squared. 8 times 192 is 1536. I could just be making this stuff up. You just write it down. Right? Let's see, it's 1600 minus, 1536 I squared over n cubed. Okay, and 8, I'm sorry, so, I've got the 6, sorry. Gotta be less sloppy. So that is 1536 over n times the last formula, n plus 1, 2n plus 1 over 6. Which simplifies to 256 times n plus 1 times 2n plus 1 over n squared. Alright, take the limits. Limit as n goes to infinity is 32 is 32. Limit as n goes to infinity, n plus 1 over n is just 1. This one's going to be 24. And this one, this limit comes out to 2. Okay, so therefore that sum is 32 plus 224 Now, I wrote a whole bunch of this stuff out and put it up in notes last week on Blackboard. Did any of you actually look at it yet? I recommend you look through it, because I basically work through one of these step by step. I write everything out nice and neatly, yes. Well, 1536 divided by 6 will give you 256. The limit is angle to this. Okay? And that's rule 1, okay? So that's why I multiply by 2 at the end. How do you feel about this stuff? We gotta do chemistry. No!